Okay, we're going to look at assigning oxidation numbers. So the oxidation number is the charge that an atom has or appears to have when electrons are distributed in terms of certain rules. So there's different rules that we're going to follow. We're going to look through these rules first of all. The first one is that the oxidation number of any uncombined element is going to be 0. Now that includes, for example, iron, if it was on its own, or hydrogen gas, H2. I know there's 2 hydrogen atoms together, but it's the same element that's together. That would be assigned an oxidation number of 0. Same with the fluorine gas here, or sodium if it was on its own. Okay, so anything that's uncombined, or if it's combined with itself, gets an oxidation number of 0. The second one is that the oxidation number of an ion is the same as its charge. So for example, if we had the sodium ion, which has a plus, that means that the sodium ion has lost an electron. So we're going to assign an oxidation number of 1 to that sodium ion. And if it was chlorine and it gained an electron, we're going to assign an oxidation of -1 to that ion. And the same for magnesium. It's going to get a +2 oxidation number. So it's the exact same as the charges here. And we can assign the oxidation number that way. That makes sense because the oxidation number is the charge that an atom has or appears to have. So here's like a direct link. Okay, it's sodium has a charge of +1. So the oxidation number is going to be a charge of +1. Okay. The third rule then is that the sum of all the oxidation numbers in a compound has to add up to 0. So for example, if we look at this example, which is sodium chloride, the sodium is going to get an oxidation number of +1, and then the chlorine is going to get an oxidation number of -1. Now the sum of +1 and -1 is going to be 0. So that links in with that rule right there. The second one is that, the fourth one is oxygen always has an oxidation number of -2, apart from a few examples such as like the peroxide. So let's look at hydrogen peroxide. Okay, hydrogen is in group 1, so it's more tempted to give 1 electron, and oxygen is more electronegative, which means that oxygen wants the electron more than hydrogen. So if it wants the electron more than hydrogen, the minus oxidation number is going to go to oxygen. So I have 2 hydrogens, 2 oxygens, and each hydrogen can give 1 electron. So I'm going to assign an oxidation number of 1 to both of those. Now they do need to balance out to give 0, okay, as there's no excess charges up here on top. So we do need a neutral compound. So to balance that, each one of these are going to get a -1 only. Okay, so they always usually have an oxidation of -2, apart from when we have peroxides. We're going to get a -1 on each of those oxygens instead, because we don't want excess charge. We want the 2 +1s and the 2 -1s to give us an oxidation number of 0 for the whole compound. Also, with this compound here, fluorine is more electronegative than oxygen. So fluorine is going to take the electron away from oxygen instead, leaving oxygen in a positive charge. Now oxygen can give 2, and fluorine just wants 1 anyway. Okay, so the oxidation number there is +2 for oxygen, and each fluorine is a -1, again giving overall sum of 0 as it's a neutral compound. Okay, so just make sure to have your electronegativity tables out when you're assigning these oxidation numbers as well. The fifth one is that hydrogen is usually assigned a +1, except when combined to a metal. For example, when we have the sodium hydride here, sodium is going to take the oxidation number of +1, and then the hydrogen is going to take an oxidation number of -1. And you can see again that the plus and minus ones are going to cancel each other out. The sixth rule is that the charge of the oxidation numbers must equal the charge of an ion. This is similar to the one that I talked about with the Na plus and Cl minus. We talk about complex ions though as well. So let's take a look at this, for example. We'll look at our nitrate ion, which is NO3 minus on the top there. So if I was to assign oxidation numbers here, our oxygen, because it is in group 6, it's always going to usually take a -2 because it wants to get to that 8 electron orbit. So it has 2 more electrons to gain. So I'm going to assign an oxidation number of -2 there. Now I have 3 of them. So I'm just going to write -2, -2, -2. And I have 1 nitrogen only. Now, see this minus up here on the top? It's not a neutral atom. So I'm going to need to keep that in balance. I need to make sure that there's still 1 more minus than there is pluses. So at the moment I have 6 minuses. So I'm going to assign an oxidation number of only +5 to nitrogen. And that leaves that imbalance there. Okay. So if we just look at the periodic table quickly, they're the rules that we need to have in our heads most of the time, and there are some exceptions. As we looked at the hydrogen and the oxygen, it depends which one is more electronegative. So always have your electronegativity table beside you when you're assigning oxidation numbers, and have those few rules in your head as well. So usually group 1 elements here, we're going to assign an oxidation number of +1 because they have only 1 electron on the outside. So their electron is usually going to go away from them and they're going to be left with a positive charge. And so on. So that'll be usually +2 for magnesium, that group 2. Transition metals, their valency can change. Electrons, there's a lot of movement in transition metals in terms of electrons. So when you're assigning oxidation numbers, try and leave the transition metals to the very last. Always go with the extremities first. Our halogens, group 7, will usually take a oxidation of -1 unless, of course, it is bonded to something that is more electronegative than itself. And then oxygen is going to be -2, and so on. Okay, so if there's any group 1, group 2, group 6, group 7, assign oxidation numbers to those elements first, and then work your way inwards, because they're going to be usually the extreme and the most electronegative in terms of the halogens, or the most likely to actually give up an electron, such as your alkalis and alkaline earth metals. Okay, so here are some examples to go through. We want you to write down the oxidation number of each element in all of these compounds. So I'll do the first few and then we can maybe pause whenever you want. So iodine, it's on its own. It's not combined to any other element. So that's rule number 1. We're going to assign iodine an oxidation number of 0. Magnesium fluoride then. So magnesium is in group 2, fluorine is in group 7. So fluorine is more electronegative. So it's going to take the electrons, and we have 2 of them. So magnesium is able to give 2 electrons, and each fluorine is going to take 1 electron. So I'm going to assign magnesium an oxidation number of +2, and fluorine an oxidation number of -1. H2SO4. So let's break it up. Each oxygen wants to get 2 electrons. Each hydrogen can give 1 electron. It needs to be balanced, so everything in this oxidation numbers, they need to add up to 0. So at the moment I have 8 minuses and 2 pluses, which means I need that sulfur to take 6 pluses for me. Okay, so now the pluses and the minuses have balanced each other out. So hydrogen gets an oxidation number of +1. Oxygen takes the oxidation number of -2. And sulfur takes an oxidation number of +6. Okay, hydrogen peroxide, the oxygen is more electronegative. So that's going to take the minus. The hydrogen can only give +1 each. And to balance that out, I need a -1 on these sides. So the hydrogen takes an oxidation number of +1, and the oxygen takes an oxidation number of -1. Again, let's take a look at oxygen. 3 of them. They all want 2 electrons. Then we have calcium, which is in group 2. It can give 2 electrons. I need to balance out the pluses and the minuses now using the carbon. So at the moment I have 6 minuses for all of the oxygens, and I have 2 pluses for the calcium. So I need carbon to take 4 pluses for me. So the oxidation number of calcium is +2, carbon is +4, and oxygen is -2. Now this compound here, we can see it has a charge on it still, so we need to keep that in balance. All the oxygens are going to take -2, and the iodine now needs to take a certain number. So altogether the oxygens are -6. I need to keep an imbalance of the negative sign. So I'm going to assign iodine 5 pluses. So iodine has an oxidation number of +5. Oxygen has an oxidation number of -2. Okay, here's some more for you. So I want you to just sign the oxidation number of the manganese in all of these compounds. Now, you're going to have to probably work out the charges of all of the elements to get the oxidation number of the manganese, but just at the very end you can just write manganese oxidation number is such and such. Okay, so there's manganese sulfate here. So again, I'm going to look at the oxygen first. So we have 4 of them. They're all going to take a -2 each. And then we're left with manganese and sulfur. So both of these are not easy exactly to assign oxidation numbers to. They're not exactly our extremities in group 1, group 2, group 6, or group 7. So what I'm going to do is look at the sulfate ion as a whole. Now the sulfate ion as a whole is a complex ion, and it takes a charge of -2 when it bonds to something else. That means that the manganese has to be a +2 as well. So straight away I can go manganese, you are +2 there. And that would make the sulfur a +6 to balance out the rest of the negatives. So that's the handy thing about learning off all of your complex ions. There's little things where they pop up where you need to remember all of the charges. Okay, the next one. Oxygen again, we have 3 of them. And then manganese, we have 2 of them. So all of the manganese, both of them, needs to balance out the 6 minuses on this side. So I'm going to assign a +3 to each of those manganese. So the oxidation number for manganese is +3 here. And over here it was +2. Okay, again, assign the 2 minuses. And we only have 1 manganese this time. So it's going to have to balance out. So the manganese takes a +4. So the oxidation number for manganese in this one is +4. Potassium permanganate then. -2 for each of the oxygens. Potassium is in group 1, so it's going to take a +1. There's no overall charge, so it needs to be a neutral compound, which leaves manganese having a +7 here. And these exercise really demonstrates how the valency and the oxidation number of the transition metals can really vary depending on what compound it's in. Okay, hopefully you're able to assign oxidation numbers now and you understand the rules. And all you have to do really is take the extremities first, look at the electronegativity values of all the elements, and then work your way through the elements assigning as you go.